So our second speaker is Dr. Akai Bachmann from Merck. Akai Bachmann studied computer science at the Technical University of Darmstadt and earned a PhD in economics while working. He began his career at Merck in 1989 as an IT system consultant. He held the senior executive responsibility for the information management and consulting unit from 1999 to 2004. From 2004 to 2007, he served as managing director of the Merck companies in Singapore and Malaysia. In 2007, he became the first CIO of Merck, with responsibility for corporate information services. Prior to his current role, Akai Bachmann was Chief Administration Officer of Merck. He joined the executive board of Merck in April 2011, and he is responsible for the electronics business sector, which he has been leading as CEO since September 2017. In October 2018, Akai Bachmann took also the responsibility for the Darmstadt side and in-house consulting. In addition, he acts as country speaker Germany with responsibility for co-determination matters. I see the number of participants growing and growing. I'm very happy for this. And now let's listen to Dr. Beckmann's talk and see you very soon.
Good morning, everybody. Welcome once again in the name of Merck to this conference. My name is Akai Bachmann and I'm a member of the executive board of Merck and CEO of our electronics business sector. I'm also responsible for our site here in Darmstadt, where we initially planned to hold this conference. Darmstadt is the place where Friedrich Jakob Merck started his local business more than 350 years ago. And it is still the headquarters of our global business today. For several years in a row, Darmstadt has been ranked Germany's #1 future city. Indeed, Darmstadt is the science and high-tech center of the Rhine-Main-Neckar region. It is a place where science and technology come to life. This is where the future is being created. And the future is here already, at least to some extent. Artificial intelligence, or AI, has already found its way into many aspects of our day-to-day lives. Many of you use translation tools, own a smartphone with face recognition, or talk to chatbots and intelligent voice assistants such as Siri and Alexa. Personalized online advertising is also based on AI, and so is Google's algorithm that determines which search results appear at the top. AI has become more and more powerful in recent decades, thanks to a steady increase in available data, always improving algorithms and more efficient computers. And in the years ahead, there is so much more exciting innovation to come. If you look at the most important technology trends, artificial intelligence obviously plays a major role. Take the MIT Technology Review, for instance. In its top 10 list of breakthrough technologies of the last 2 years, you find trends like AI-discovered molecules, tiny AI, multi-skilled AI, or large natural language computer models like GPT-3. What do all these trends have in common? It's the enormous amount of data that is needed to sustain them. Today, there are 50 trillion gigabytes of data existing, and data continues to grow at more than 30% on average per year. According to estimates, the amount of data generated worldwide will reach more than 170 zettabytes by 2025. Just in case you wonder, this is a number with 21 zeros. Data is becoming the main resource of our digital living today. Artificial intelligence is one of the drivers of this data explosion, along with 5G, autonomous driving, and the Internet of Things. All these technologies need high computing power. They require or create vast amounts of data. This is where our company comes in. With our materials and solutions for the semiconductor production, our electronics business sector delivers the basis for powerful technologies such as AI. Without these materials, powerful computer chips would be unthinkable. The data explosion has led to a lasting need for even faster and more powerful microchips. At the same time, these chips must not become bigger. They still need to fit into a smartphone. The required chips are becoming more and more challenging to design and to develop. Normal chips like CPU or GPU are now complemented by special AI chips. These chips deal with the exponential data growth in a faster and more efficient and more energy efficient manner. To bring artificial intelligence to the next level, materials play an increasingly critical role. Only with the right semiconductor materials can we develop more powerful computer chips or even new computing architectures. So let me explain. Today, nearly all computers are based on the von Neumann architecture, which is particularly suitable for very precise calculation of complex models. The architecture has proven itself over decades and has been continually optimized. You have certainly heard of Moore's Law, named after Gordon Moore, the former CEO of Intel. Moore's Law is an observation that the number of transistors on a chip doubles every 2 years at lower cost. Some people argue that Moore's Law is reaching its limit. Others, among them Intel itself, are not expecting a funeral for Moore's Law anytime soon. Be that as it may, the point is to support the increasing demand for more data, technology has to push the limits of what is physically possible. So how do we do this? One example is 3D Nand. For a longer time, planar 2D chip architectures dominated the market. 3D NAND technology now makes it possible to use the third dimension in the manufacturing of computer chips. A 3D NAND chip is like a high-rise building in which the memory cells are stacked in layers on top of one another. If you compare the surface area and the height of a 64-layer 3D NAND chip with a skyscraper, today's technology has already reached 3 times the height of the world's tallest building, the Burj Khalifa. The von Neumann architecture is still indispensable and will continue to be further developed in the future, but it is reaching its limits in some aspects, especially when it comes to AI, which requires a huge number of calculations. Computers have to store and process data simultaneously or perform tasks that include pattern recognition, for example. The von Neumann architecture is not particularly suitable for this, especially as regards efficient energy consumption. Therefore, research institutes and companies around the world, including Merck, are looking into the future of computing beyond the von Neumann architecture. New computing technologies are needed to resolve this issue, for example, neuromorphic computing or quantum computing. One thing, however, stays the same. Materials continue to play a key role in developing these technologies. So far, my short digression into the world of materials. So now let's go back to Merck. As a leading science and technology company, we also drive the development and use of artificial intelligence for our business. In all sectors, we develop new business models, products, and services that are based on AI and deep learning. Across Merck, we optimize our operational and manufacturing efficiency with the help of AI. For example, our healthcare colleagues initiated a digital pathology project. They scan thousands of images of tissue samples from cancer patients. The idea is to train the AI so that it can differentiate healthy cells from cancer cells. Can you imagine an oncologist to upload a tissue image to the cloud and obtain an accurate diagnosis within minutes? AI makes it possible. Deep learning is also a topic when it comes to basic research at Merck. We are currently setting up research groups that aim to find out how biological brains and machines can abstract information. We also see more and more industrial AI applications, for example, when it comes to the smart factory. At Electronics, we are testing the application of deep learning in quality assurance. We scan photos of samples of our liquid crystals, which are used for LC displays. As a result, the AI is trained to recognize defective batches. These defective batches can then be removed quickly and effectively from the production process. This again ensures even higher quality of our liquid crystals. We are also investing in artificial intelligence to make use of its full potential. Last year, we invested in SynSense. SynSense is a neuromorphic computing startup, and they develop AI processors and sensors that provide an exceptional combination of ultra-low power consumption and low latency. This is used for a broad range of edge applications in smart homes, smart security, autonomous driving, drones, or robots. Bioelectronics is another emerging innovation area where AI can play a big role. Here we join forces with B. Braun. This collaboration represents a milestone in the new bioelectronics innovation field of Merck. This is particularly exciting for us because we can build on our experience and expertise in healthcare and electronics. Bioelectronic devices are very promising when it comes to improving therapies for patients with chronic inflammatory diseases. True to its motto, Science for Good, Merck is keen on developing medicines and intelligent devices that provide ongoing care for patients beyond their treatment. I talked a lot about technology now, but there's one additional important topic I want to highlight. We do need human intelligence to steer artificial intelligence. The best technologies are worth nothing if people are not using them properly, or even worse, are abusing them. I see two important aspects to the people dimension of AI. The first one is capability. A recent report showed that data science and analytics, artificial intelligence, and machine learning are the top future skills in our industry. We need to attract talent and also upskill our existing workforce on these topics. The second one is even more important. It is about data culture, how data is being handled in a company. We need our people to live data, and we need our leaders. They have to lead by example when a company wants to establish a data-driven culture. In order to harvest the value of data, you need to make sure that everybody shares the same vision and has the right skills and tools at hand. The task of leaders is to promote a data culture and encourage their teams to make data-based decisions. I was happy to see that there's also a human impact track in today's conference, chaired by our Director of Bioethics and Digital Ethics, Jean-Renaud Charton. This is important because we need to ensure that data and AI are used ethically and in a responsible way. If used in the right way, AI and data have an enormous potential for good. But there is also a risk of unintended harm if they are not used in the right way. We therefore need to always carefully evaluate potential risks and benefits when it comes to AI and data applications. We at Merck are thought leaders in digital ethics. We have established a digital ethics advisory panel and developed a code of digital ethics. By defining our principles in handling data and AI, we make sure to apply AI in a responsible way for our patients, our customers, our employees, and society as a whole. Again, thank you for giving me the chance to share my views on artificial intelligence with you. Enjoy the rest of the symposium, and I'm sure you will find it insightful and encouraging.